Hi everybody, and welcome to the third video on vectors. In this video, I don't want to introduce any new concepts. What I want to do is integrate the vector material with past material. So I want to combine the use of vectors with the use of loops and if statements and random choice. I basically want to show you a combination of all those things working in concert to show you how powerful they are. So in this video, I'm going to write a sophisticated program for you to show you all of this integration. And in particular, I want to show you what I do when I sit down to write a sophisticated program. So I'm going to spend a lot of time thinking out loud to provide a model for you when you sit down to write a sophisticated program. So I apologize ahead of time for the length of this video. Even though I am not introducing any new concepts, this will be one of the longer videos of the course, and the reason it is longer is because I really did want to model for you sort of planning to write a program, thinking out loud, all of these sorts of things, and those things take some time. Okay, so what I'm going to do for you is write a program that lets you play the game NIM. You have probably never heard of this game before, because it's not terribly exciting, but in my own work it comes up fairly frequently as sort of a canonical example of a combinatorial game, so let me just give you the rules. You start with several piles of rocks. You can have as many as you want. This is a two-person game. On your turn, you choose a pile. So there's like pile 1, pile 2, pile 3, whatever. Choose your favorite pile, and from that pile, you take as many rocks as you want. Okay, so the person who takes the last rock wins. So you could have two piles, and maybe one pile has 5 rocks, and the other one has 7 rocks. So if it's your turn, you start by choosing a pile. You could choose either the 5-rock pile or the 7-rock one. If you choose the first pile, you can take 1, 2, 3, 4, or 5 rocks from that pile. If you choose pile 2, you can take up to 7 rocks from that pile. So just to give you a feel for how this game goes, suppose that it's my turn, and I choose pile 1. I should not remove 5 rocks from pile 1. Why is that a bad move? That's a bad move because the person who removes the last rock wins. So if I choose pile 1 and I take all 5 rocks, then what you should do on your turn is choose pile 2 and just take all of the rocks from there, and then you would win. Okay, so that's how the game works. So what we are going to do is write a program that lets the user decide how many piles of rocks there are, how many rocks are in each pile. It's a two-person game. We'll play it against the computer. So whenever you use a computer opponent, there are lots of options for you as to how the computer will play. For the sake of brevity, we'll have the computer play in easy mode. We will have the computer do the simplest thing possible. So what does that mean? The computer's choices will be random. So the computer will choose a pile at random, and once it has chosen a pile, it will choose a number of rocks to remove at random. So before I go to the compiler and write this program, let me just think out loud for a little bit about what I should do. So at the very beginning, I always think about, well, what kind of variables will this code need? Because that's always something you can do if you don't know anything else. If you are stuck, you can always ask yourself, well, what kinds of data do I need to store? And what data types are those things? So at the very least, you have to let the user tell you how many piles there are. So you should create a variable that allows them to do that. An integer vector that keeps track of the stone pile data. Okay, so why a vector? Well, I can have as many piles as I want. So I can have a pile 0, a pile 1, a pile 2, a pile 3, etc. And each of those piles can have its own size. You can have 5 rocks or 7 rocks or 8 rocks, whatever. So the most natural way to store all of this actually is to use a vector, where the positions of the vectors, position 0, position 1, position 2, that represents what pile you are talking about, and the entry at a given spot tells you how many rocks there are. So that's what I mean by stone pile data. You create a vector that keeps track of which pile you're at and how many rocks are in each pile. The game keeps going until all the stones are gone, so you should probably keep track of how many stones there are in total, right? So this game here, there are 12 rocks total at the beginning. So if on my first turn I remove all 5, then now there are 7 total, right? So you should keep track of that, because what decides when the game is over is when there are no more stones. Variables that on the user's turn allow the user to specify the pile and then choose a number of stones to remove from that pile, and the same for the computer. So in other words, you have to ask the user, which pile do you want? And once they've told you that, you have to ask them, well, how many rocks do you want to remove? Each of those things will require a variable. And of course, the computer's turn is basically symmetric, right? The computer also needs a way to choose a pile and to select a number of stones to remove. Okay, so that's given me kind of a starting point. So I'm going to go to the compiler in a second. I've already loaded all of these variables in there. But once you've sort of talked this out, you can always just ask yourself, what will this program look like? So in general, especially if you are writing something sophisticated, you should probably not just sit down and start writing code. You can if you want to, I mean, there's nothing wrong with that, but generally speaking, it gets really easy to lose the forest through the trees if you start that way. So a way to help yourself see the big picture, especially as you're actually coding the details, is to create sort of a little pseudocode schematic like this. How will the program go? Well, I'll declare my variables like always. I'll get the number of piles from the user, and then I'll have to let the user fill in all of the entries of the vector. I'll have to ask them how many rocks are in pile 0, how many rocks are in pile 1, how many rocks are in pile 2, etc. That will most likely require a for loop. I don't know of any other way to do that, really. You'll then need to figure out how many stones there are in the game. And then, as long as there are still stones in play, what should happen? You should let the user choose a pile and choose a number of stones to remove. If now, there should be a 0 here, but that's fine. I was missing from both. There must have been some issue with the compiling here of this slide, but anyway, it's fine. If the total number of stones is 0, then you win, right? And the game is over. Otherwise, though, the computer gets a turn, don't they? So if the total number of stones is not 0, the computer gets to go. They do the same thing. They choose a pile, choose a number of stones to remove, and then we again check if the total number of stones is 0. And if it is, that means you lost. You, the human. The computer took the last stone and beat you. Okay. I am not claiming this is the only way to do this program. I am not claiming it's the best way to do this program, whatever best means, okay? This is just what occurred to me, how I would walk through this. There are plenty of other ways to do it. But anyway, it's just nice to be able to talk out ahead of time what you were going to do. So if you were to play this game on your own with your buddy, this is basically what you would do, right? Okay, so now let me go to the compiler and just implement all of this. So here are the variables that I mentioned, most of them. Number of piles. Total stones is 0 so far because I don't have any data yet. I created a variable for the user to pick a pile, and then for the user to pick a number of stones to remove, and same for the computer. So here's the variable that the computer will use to pick a pile, and here's the number of stones the computer will use. Okay, so first let's just ask the user, how many piles are there? And get that from them. Number of piles, okay. So now once we know that, we can create an integer vector. Seems most natural to call it piles. And how many piles are there? Well, number of piles is how many piles there are. So if the user right here says there are 10 piles, then I've just created a vector of size 10, each entry in the vector will keep track of the size of each pile. Okay, so now let's let the user tell me how many things are in each pile. Oops, 0. Scroll down a little bit. So I'm just going to go through the vector entry by entry and ask the user how many rocks are in pile, whichever pile I'm currently at. And I guess we should warn them. Note, we start with pile 0, not pile 1, right? So the user might think we're going from 1 to 10 rather than from 0 to 9. Now, of course, if you wanted to present the user the numbers 1 through 10, you could do that, but we're not going to do that. That's just an extra layer we are not going to worry about right now. So let's just run this real fast. Oh, and then let me actually print this out. Oh, of course, once I ask them that, I have to get it from them, don't I? So what do I need to now do? I need to read in the entry at position I. Okay, so here's how the user can fill in. And by the way, I'm not going to do a ton of this just in the interest of time, but notice you can do things like right here. What if the user decides to enter a negative number right here? Well, that would be bad because you can't have a negative number of rocks. And also, we probably shouldn't let them enter 0 either, because if they enter 0, then what was the point of having all these piles? So I'm going to do something like this. As long as what they just gave me is less than or equal to 0, I'm going to tell them, hey man, positive numbers of rocks only, bro, and then make them try again. Okay, so this for loop here just goes entry by entry and gets the number of rocks in the given pile. And then if the user is a joker about it and tries to give you negative numbers or 0 as a pile amount, you'll make them retry until they do it properly. Okay. So here's a while inside of a while, right? This is a little like validation check loop, just making sure they are giving you data as you want it. Okay, so once that's over, we can tell them like, well, okay, game board is set up, you know. Okay, here is the starting configuration. So here's what the piles actually look like. Line here, and then I'll just do my standard print, my standard vector printing loop here. So I less than number of piles, I plus plus. So I'll see out the number of rocks at pile I. I'll separate with a space. And then once that's done, I'll just new line. Okay, so we are nowhere close to done yet, right? But we've done a lot of work so far. So let me just run this and see that it's doing what it's supposed to do. Okay, how many piles are there? Let's just do 5. How many rocks are in pile 0? I don't know, how about 10? How about 3? How about 6? How about -4? Positive numbers of rocks only. Okay, how about -4? How about -5? Okay, fine, you beat me. How about 7? How about 9? It says, okay, here's the starting configuration, 10, 3, 6, 7, 9. Okay, just as I told it to. So there are 10 rocks in the first pile, 3 rocks in the second pile, etc. Okay, so now for the hard work, right? So all we've done so far is set up the start configuration of the game, right? Now we actually have to let the user and the computer play. Okay, so as we said in the schematic, what we need is something like this. As long as total stones bigger than 0, we play, right? That's the condition that keeps the game going. As soon as total stones become 0, then we quit. So just like it says here, total number of stones. And yeah, so in this code, I actually call it total stones. Okay. So before we jump into that loop that plays the game, though, we should probably figure out how many stones there are, right? I mean, right now, total stones, there it is. Right now, that's 0. So right now, we don't know how many stones there are at play in the game. So let's figure it out. The way we can do that is just, here we go. Let's just go through the vector of piles entry by entry and just add them all up. So it would look like this. Total stones equals total stones. So total stones starts at 0, right? So initially I haven't done anything yet. And then just add the number of stones in pile I. So when this loop starts, total stones will be 0 plus the number of stones in the first pile, pile 0. Then when the loop runs again, we'll have the number of rocks in pile 0. Then I will be 1 and we'll tack that on. So this is a friendly loop. We've seen this before. So this will calculate the total number of stones at play. Okay, so now we actually have a condition going for our game. So now we actually have to code gameplay. So first, let's ask the user to choose a pile. So choose a pile, keeping in mind, right, that positions start at 0. Doesn't hurt to help that, or to tell the user that. Okay, so now let's get from them this variable I created called pile choice. I created it way back up here, pile choice. That was created to give the user a way to tell you this. Okay, and then we could say, how many rocks do you want to remove? And then we can get, let's see, what did I call it? Number to remove. That makes sense. So notice also, right, the computer itself doesn't care what you call things. So way back up here when I created these, I could have called this X, this Y, this Z, this A. I could have done that, and the computer doesn't care because the computer doesn't know English, okay? But you guys know English and you have to read this. So notice this is much easier to read than otherwise would have been because of the names I gave things. So again, it's not like I would dock you points for using less helpful names, but it becomes much easier for you, for your group mates, and for me to read if you use suggestive names. Okay, so we can again here, if you want to, as soon as they give you this, you can put another validation check in if you want to. And again, you don't have to do this every time, but just to give you a flavor for how this goes. If number to remove, well, what if they're a joker and they tell you, I want to remove no rocks, or negative numbers of rocks, right? They should be forced to choose again. Or maybe, I don't know, number to remove is what? Bigger than the number of rocks they currently see? Let's suppose there's only 10 rocks in this pile and they decide to enter 13. Well, that's bad. So again, this right here, that means the number of rocks in the pile that they chose. Right? Here's their pile choice. That's like a 2, 3, 4, like pile 2, pile 3, pile 4. And then piles bracket that is the number of rocks actually in that pile. So what am I saying here? Like they just gave me a number of rocks to remove. That number might be too small, right? It might be 0 or negative, which is bad. Or it could be too big. It could be more than the number of rocks there are. So in either case, I'm just going to tell them like invalid number of rocks to remove, try again, and get their choice again. Again, you don't have to do this every time, but just to give you a flavor of if you want to keep the user honest, you can always just throw these little validation check loops in there to just keep prompting them until they behave. Okay, so once we do all this, let me just clear a little space here just in case. So I just printed this to the screen. Let me now do an inline. Okay, so what should happen? As soon as they make their choice of pile and the number of rocks to remove, what should happen? Well, we have to take the number of rocks inside the pile they chose. So there's the number of rocks inside the pile they chose. We have to, decrease that by the amount they told us to decrease it. Oops, minus number to remove. So whatever that value used to be, you got to take those rocks out of there because the user told you to. And then what else do we have to do? Well, remember, our loop condition depends on the total number of stones in play. So as soon as the user takes those rocks out, we have to reflect that also. Right? The total number of rocks has also gone down. Right? So not only has the pile itself decreased in size, but the overall number of rocks has also decreased in size. In both cases, they've decreased by the number the user decided to remove. Okay, so we can tell them, here's the game board now. We can just show them what their choice did. And let me just print the board again. So where did I print it before? Right here. It's the same printing loop, right, as always. Okay, there it is. Okay, so we're actually pretty close to being finished here. So let's just talk through real fast what we've done so far. Let me just recap what we've done. At the very beginning, we just let the user set up the board, right? How many piles of rocks are there anyway? And then we let them tell you how many rocks there are in each pile. That happened here. Once we got that from them, we just showed them what they did. We then calculated how many rocks there are in play, and then we set up our gameplay loop that looks like this. As long as we still have stones on the board, we're going to keep playing. And the user gets to go first. So, choose. So we ask them to choose a pile. We ask them how many rocks to remove. We make sure, in this case, that the number to remove makes sense. Once we have that choice, we just force the pile to decrease in size by how much they said, and we force the total number of stones to decrease in size. So that's what it means to give the user their turn. Right? They got to choose a pile. They got to choose a number of rocks to take away. Okay, once their turn's over, you can now check if the total amount of stones is 0, then what happens? Well, they won, right? If the total number of stones is not 0, now it's the computer's turn, right? And by the way, I haven't been doing this, but it really is good practice to do things like this. You don't have to do this, but to add comments that say what's happening, so that a casual reader could come in and figure out what you're doing. So like right here, you could say something like, this for loop sets up the game board. So, and then right here you could say humans turn, and then right here you could say, oh, so now that the human must not have won. So if the human hasn't won, the computer gets a turn. Now you could do things like this, right? You don't have to, but again, if you're reading new code or I'm grading you or something, it can be helpful to see. Just sort of short little summaries of what's happening. Okay, so now it's the computer's turn. Okay, so the computer, unlike you, has no intention or something, right? It doesn't really make choices unless you teach it how to make a choice. So what did we say? We said, it says somewhere in here, easy mode, the computer's choices are random. Okay, well, remember how you played. First, you chose a pile, then you chose a number of rocks to remove inside that pile. So you made 2 choices. The computer also has to make 2 choices, and it will make them randomly. So first, computer pile, is that what I called it? Let me see. Yeah, computer pile. How does the computer choose a pile at random? Well, it just chooses a number between 0 up to, number of piles minus 1 is what it does. It chooses 0, 1, 2, 3, 4, 5, etc. up to the number of piles there are minus 1 at random. So what does that look like? It looks like this. What we've done before. Choose at random for me a number between 0 and number of piles minus 1. So there you go. The computer has now chosen a pile at random. The problem with this, though, the problem with the computer making its choice at random is that it maybe chose a pile that has become empty. Okay, so at the beginning of the game, way back up here, when you were setting up the board, I forced you to enter positive numbers of rocks. But, if this is the computer's fourth turn or something, if this is the fourth run through this loop, some of the piles might be empty now. You want to make sure the computer always chooses a non-empty pile. So you can do something like this. While the number of rocks inside the pile that the computer chose at random, if that's empty, you got to make the computer choose again. Okay, so again, at the fourth or fifth turn of the computer, right, there might be empty piles. You do not want the computer to choose an empty pile because then it can't take anything. So, if this line of code here happens to choose an empty pile, like if it chooses the number 1 and pile 1 is empty, you should make the computer choose again. So as long as the number of rocks inside the computer's pile is 0, let the computer choose again. Okay, so once the computer has a pile in mind, now it has to choose a number of rocks to remove. So computer number of rocks or something is what I called it. Let me see here. Computer number. Okay. So now let's let the computer choose a number of rocks to remove. Well, it chooses a number between 1 and up to the number of rocks there are. So that looks like this. 1 plus rand percentage number of rocks inside that pile. All right, so that starts at 1 and that goes up to the number of rocks inside of that pile. We've now let the computer choose a number to remove at random. Okay, well once we've done that, now let me just copy and paste these 2 lines of code here. Just like for you, once the computer makes choices, we have to now reflect those choices in the sizes of the piles and the total number of stones. Okay, so here, let me just write computer number, and this here is computer pile, and this here is computer pile, and total stones now is knocked down by computer number. Okay. So now I can tell the user after the computer's turn, the board looks like this. And I would just print the board again. Okay. So once the computer has taken its turn, you should again check to see if the computer just won. So if immediately after the computer's turn, the number of stones is 0, you have to tell the user, lost buddy, sorry, right? Okay, so if after the computer's turn, the number of rocks is now 0, that must mean the computer took the last rock. So the computer won, therefore you lost. Okay, so let's run this now. Let me just say that this code is on Moodle, so you can play with this yourself if you want to. But let's now run this, and I don't know, it should work, but you never know. Generally speaking, you don't wait till the very end to run it. For the sake of time, that's what I did. But generally speaking, as you add certain things, you will run the code to see if it's working properly or not. So for example, let's see, where is it? Right here, like if I were writing this and I didn't care about time because I were making a video, where's my turn? Right here. As soon as I wrote the code for my turn, I would have run the code to see if it respected my turn properly, if it were doing what I wanted. Okay, anyway, all that to say, let's actually run it now and see what it does. I don't know, 4, 7, 6, 5, 8, whatever. Okay, so there's the game board. Okay, I'm going to pick pile 0. I'm going to remove 2 rocks from that. Okay. So, okay, here's the game board now. So notice, right here, that 4 got knocked down to a 2. The other numbers stayed the same. Then, because I forgot to put a new line in between, it says after the computer's turn, right? So I didn't make it pause or anything before the computer took its turn. So after the computer's turn, the board looks like this. So what must the computer have done? It must have chosen pile 1 at random, and then chosen the number 1 at random as a number of rocks to remove, because 7 got knocked down to 6. Okay, so now I'm going to speed things up a little bit. I'm going to choose pile 4, the very last one. I'm going to remove 8 rocks from that. Okay, so that 8 got knocked down to a 0, and then it says after the computer's turn, that 5 became a 0. So the computer, I guess, is also in a hurry here. Let me now choose pile 2. I'm going to remove all 6 of those. The computer chose the first pile and took 1 from there. Okay, so I'm going to let the computer win, I guess, here, because I'm going to choose pile 1, which again is the second pile, right? Confusing. I'm going to take all 6 of those. Therefore, after the computer's turn, he has no choice but to win, doesn't he? He takes that final one, and then it tells me you lost, and it's over. Now that's cute, isn't it? You have to admit that's cute. It worked. I have to admit, I cheated a little bit. I printed out the code I wanted, and I was reading some of it next to me. So, you know, I'm like you guys, right? Usually the first time I write something, it doesn't work properly. Especially if it's something, you know, like I don't have an issue with the logic or something, but when you write this much code, this isn't a ton of code, but it's a non-trivial amount, right? If you just sit there and write it, usually you make 1 or 2 mistakes, right? So anyway, so it worked, and it's nice. So what all did we do here with this program? We have loops all over the place, don't we? We have ifs, else's all up in your face. We got randomization, right? No strings, unfortunately. So we didn't integrate everything. But here's an example of a pretty sophisticated and pretty powerful program that you guys can now write using the tools that we have. In particular, vectors, okay? Because without vectors, I just don't know how you record all the pile data. Or at least I don't know how you do it in a nice way, you know? This single line of code here just basically called into existence this game board that I could then fill in. So without this vector, I don't know how you do this. It would at the very least be much, much more obnoxious. Okay, so I hope this was helpful for you. In class, you will write a couple of sophisticated problems of your, or programs of your own in a vein similar to this.